Hi, it's Ms. Parrott, and in this video, I'm going to show you an example of a problem using chi-square analysis. Chi-square analysis is a statistical tool that you can use to determine whether or not the expected results of an experiment and the observed results are actually significantly different or not. So let's just practice this problem. In this situation, a breeder has a black cat and a white cat and mates them. And he expected for there to be equal number of kittens, of black ones and white ones, an equal number. But after having 20 kittens, 15 were black and 5 were white. And yes, those numbers are different, but are they different enough to be considered statistically significantly different? So our question is, was the difference significant enough to reject his hypothesis, right? So we're going to use that chi-square tool. The equation for chi-squared is, well, this is it, chi-squared. Note, this squared right here is not like a function. You're not going to be using this for calculations in any way. It's just sort of the title of the equation. All right, so chi-squared equals the summation or sum of the observed value minus the expected. You're going to square that, then divide by the expected value. So let's do this example. I like to set up this chart so that I'm sure that I walk through all the steps to make sure I have everything I need for my calculation. All right, so reading the problem, we've got our cat colors black and white, and so we observed 15 black ones and 5 white ones. So we're just going to write that here. But we expected that there would be an equal number, which would be 10 and 10. So those are our expected. All right, we're just going to go across. So with black, the observed minus expected is 5. And then we square that, and that's 25. And so then we take this number, 25, and divide by the expected value of 10. That, of course, gives us 2.5. All right, now let's look at the white cats. So we have observed minus expected. That's going to give us -5. Square that, we'll get 25 as well, which, just like the other, gives us 25 over 10, which equals 2.5. All right, and then we're going to add these up, right? So chi-square is going to equal this 2.5 from the black cats plus the 2.5 for the white cats. And so our final chi-square value is 5. 2.5 plus 2.5. Okay, but what does this mean? What does this number do for us? Well, it by itself doesn't do anything, but we're going to compare it to a number on this chi-square distribution chart. So I know you won't be able to see it perfectly, but here's the kind of general idea. All right, so I have to pick a number on here to compare my chi-square equals 5 to. So the way I do this is to figure out the column, I use P equals 0.05. Hope you can see that. And then there's a degrees of freedom, there's a row. The way I figure out degrees of freedom is I take the number of groups I have, which is 2, black cats, white cats, and I subtract 1. 2 minus 1 equals 1. So I have 1 degree of freedom. So that's the row I'm going to use when I go over. And that value, that critical value that's found, I believe you can see this right here, is 3.84. So critical value is 3.84. All right, so how does that compare to our 5? Well, our chi-square of 5 is greater than 3.84. 84. But what does that mean? If we look at our chart, I'm going to try and hold this to where you can see it. Yeah, here we go. If our value is less than our hypothesis, less than our critical value, we accept the hypothesis. But if our value is greater, we reject the hypothesis. Now, our critical value is 3.84. So our critical value is 3.84. Our chi-square value was 5. So since 5 is greater than 3.84. So this breeder thinking it's going to be 10 to 10, that hypothesis is rejected, which means that the differences aren't just due to chance. There's something outside going on that would influence the results, maybe genetics, maybe some other outside situation. So that's just a quick and easy example of how to do a chi-square analysis. I hope that helps you do your own practice problems.